Okay, everyone, lesson 5.1, natural log differentiation. This whole chapter, we're going to be looking at some other types of functions, our log functions, our e to the x functions, and doing derivatives and integrals of those functions. So far, we really only know how to do derivatives and integrals of polynomials, but that's going to change this chapter. First couple slides is just an intro to the natural log function, which you should recall from pre-calc. And also IAT, you did these then. Here, slide 2, here are some properties of logs that you should recall that we may need in the future. But now let's get to the good stuff. Slide 3, the derivative of the natural log function. So it lists 3 different versions of this here, but they all really say the same thing. The one you'll really need to key in on and remember is this middle one here. This is the crux of it all. The derivative of natural log of some expression u. And this u, don't confuse this u with the u's we did in the previous lesson. They're totally unrelated. They just choose the letter u just kind of randomly here. So the derivative of a natural log of some function u is equal to this. Du divided by u. Or in other words, the derivative of what's inside the log. So if there's a u inside the natural log, then du means its derivative, divided by just u. You just leave what's inside the natural log alone. You just write it on the bottom. So it's du over u. And all 3 of these things really say the same exact thing. Okay? So let's try a couple examples here. We're going to do this slide. Examples A, B, C, and D. So the derivative of a natural log of 2x is equal to du over u. So if u is this 2x thing, then du, aka the derivative of 2x, is just 2, divided by u. You just leave it alone. So 2 over 2x, which you could simplify into 1 over x. Okay, that's it. It's du over u. Same thing with part B. The derivative of u. So if this whole inner piece is your u expression, so du is going to equal 2x, right? That's in the top, and then in the bottom you leave the u expression alone. You just basically rewrite what's inside the ln, and that is your derivative. Okay, now for parts C and D. These are a little tougher. I'll put little stars next to them because you need to utilize some rules we learned way earlier in the year. Remember the product rule? And remember the chain rule? Back from chapters 3, when we first learned derivatives, the product rule. Right here in this example, you actually have 2 things being multiplied. You have x times ln x. So the product rule, if you recall, says to do 1 times the derivative of 2 plus 2 times the derivative of 1. So in this example, the x is the r1 and the ln x is r2, right? So the first thing is x times the derivative of the second thing. So the derivative of ln x is the derivative of what's inside the ln, which is really just a 1 for this example, divided by what's inside the ln, x. So that's the first half of our product rule, 1d2, plus 2, the second thing, which is ln x, times the derivative of the first. Well, the first thing is x, so the derivative of that is just 1. And then you would just clean it up a little. These x's will cancel out right here, right? So you're just left with 1 plus ln x times 1 is just ln x. And that is your derivative, 1 plus ln x. And then finally, letter D. Here we need a chain rule because what we have is actually a function inside another function. We have an ln x inside a cubing function. So the chain rule, if you recall, says do the outer shell, do the derivative of the outer thing. The outer thing is this parentheses being cubed. So the derivative of that would be, you'd use a power rule. You'd bring the 3 in front, you'd leave the inside alone, you'd drop the exponent by 1. That's the outer derivative of this outer function, this cubing function. Then the chain rule says, okay, take the derivative of the outer piece and multiply it by the derivative of the inner piece. So the inner piece is this ln x thing. So we would do the derivative of that, which we should know by now. The derivative of ln x is just the derivative of x divided by x. So the derivative of x is 1 divided by what's inside the ln, which is x. And then finally we could just clean this up a little. We could put the 3 ln x quantity squared in the top over x. And that is your derivative. We'll try more examples in the next video.